Hi everybody, I'm here making a video. I know last week some of you left confused from the tutoring session about epistasis, so I made a video to help explain that more. So, with recessive epistasis, you are going to have a 9:3:4 ratio. You're going to have the epistatic gene, which is the one that's covering up the other gene, and you're going to have a hypostatic gene, which is the one that's being covered up. Also, you should keep in mind that these genes have to be in the same pathway. I'll explain that in 1 second, but I'll go to the problem first that she had in class. So, when you had the cross, you produced all blue progeny for the dihybrid cross. And then you ended up with a ratio of 9:3:4. The 9 represents the wild type. The 3 represents like the heterozygotes, and you would expect in Mendelian genetics another 3, but instead we're getting the 4 because we have a little w, little w. That little w is the epistatic gene that is covering up the M, which is the hypostatic gene, producing white progeny. And then the little w does it again and covers up the little m and produces white progeny once again. So with recessive epistasis, you are looking at something that has two alleles that need two copies of the alleles to cover up another genotype. And that's what we see here, and that's why we're getting a 9:3:4 ratio. Now, when I said that the genes have to be in the same pathway, what I mean is that you need these guys in the same pathway to be able to control this gene. If these guys weren't in the same pathway, they wouldn't be able to, whoever was this epistatic gene and whoever was the hypostatic gene, they wouldn't be able to affect each other if they weren't in the same pathway. That's why it's crucial that these guys are in the same pathway to be able to show recessive or any type of epistasis, because that's controlling the other gene in the pathway. Also, I want to note that the other example, the complementary, used the same flowers as the recessive epistasis, and that's not saying that those flowers can have both those mode of inheritances. She was just using the same example. So don't think that that flower can show complementation and recessive epistasis. It always just shows one. Also, when we're looking at the next one, for a dominant epistasis, where you have the 12:3:1, you're getting all the genotype from what would be considered like the normal, the wild type, and you're getting all the genotype or phenotype from the heterozygote one. Because this one, you just need the one allele, so say that it's big A, you just need to show big A to be able to see this phenotype. So that's why you're getting the 12:3:1 ratio. Because this guy is not going to have the epistatic gene, so it will be able to show its trait. And this guy has no epistatic gene because it's all recessive alleles and won't show the epistatic gene, so nothing will be covered up and show that it is homozygous recessive. Also, I want to point out that when you're taking exam 2, if the question shows that the parents are producing progeny with 3 different phenotypes, then you're going to look for a ratio that has 3. If the problem is showing and you're only getting 2 phenotypes, then you need to look for one of the ratios that has 2. That's just a good way to help check yourself. Don't just do it that way. You should check yourself, but that's a good way to always check yourself. I think that's it. I hope these videos help. I'll see most of you in tutoring later this week. Thank you.